All right, here I want to take a look at um, a limit that involves a radical in the denominator, and if it's a rational function as well, and how to deal with that. So first thing, we need to see that if we plug in the 9, if we evaluate this function at x is equal to 9, will we end up with 0 in the denominator? Yeah, if we plug in a 9 there, take the square root of 9, we get 3. 3 minus 3, it's going to be 0. So we got to figure out some way to find an equivalent function here. And we can't just factor it like we did for the other ones. That's the problem. And so what we need to do is figure out some other way to find equivalent function. Well, remember, if you remember how to rationalize the denominator, that is what we're going to do here. If you don't remember, well, what we're going to do is multiply the top and bottom of this fraction by the same thing, and thus it remains an equivalent fraction. Whenever you're trying to rationalize a denominator, what you want to do is multiply by these same values, but you want to change the sign in between. Okay, so what we're going to do is multiply top and bottom of this rational function by the square root of x plus 3. Okay, now a common thing that people do is they'll go ahead and they'll multiply this out. Boom, 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 boom. Now let's take a step back for a moment and not do that. So let's write it simply. So this is just going to be x minus 9 times the square root, square root of x plus 3. Keep it grouped up there. Okay. Now in this denominator, when we use like FOIL to multiply this out, notice that we have the different signs here. So those middle terms are going to cancel out. So all you're going to be left with is the square root of x times the square root of x, which is going to be just x. And then you're going to have the negative 3 times a positive 3, which is going to be negative 9. And now you may see, oh, well, that's why we didn't multiply the numerator. Yeah, look at that. X minus 9 here, x minus 9 here. That is what we're looking for. If we don't have that, we get problems. But since we do have it, I can reduce the top and bottom by x minus 9. And so what I am left with is the limit as x approaches 9, of, now it's just the square root of x plus 3. This is an equivalent function to the function we started with. Can we evaluate it when x is 9? Yes, we can. And so what we're going to end up with is the square root of 9 plus 3, which is going to be 3 plus 3, which is 6.